Shiny surfaces are literally everywhere you look. Your phone, your car, even your jewelry. But behind that gleam, there's this fascinating and sometimes pretty dangerous world of science. Today, we're going to pull back the curtain on the amazing tech that actually makes things shine.
I mean, it seems like a simple question, right? But the answer is getting way more complex and, honestly, a lot more interesting. What if I told you that the perfect gloss on your kitchen faucet and the specific color on a life-saving medical implant, what if they came from the exact same family of revolutionary technologies?
You see, for decades, getting that brilliant shine has come at a really steep price. The industrial processes behind these coatings have, for a long time, relied on some incredibly hazardous chemicals. We're talking major risks for workers and for the environment. But thankfully, that is all starting to change. Okay, so let's get right into it. To really appreciate this new revolution, we've got to first understand the dark side of shine.
For the longest time, getting that perfect, durable finish meant using some seriously nasty stuff. I mean, think about it. Giant vats of cyanide-based solutions for silver plating and hexavalent chromium, which is a known carcinogen for creating those hard, tough surfaces. Were they effective? Oh yeah, for sure. But at what cost? The real challenge has been, how do you get that same amazing performance without, all the poison?
And that brings us to the really exciting part, the green revolution happening in surface engineering. Let's take a look at 3 game-changing technologies that are completely rewriting the rulebook. First up, we've got something called deep eutectic solvents, or DES for short. The best way to picture it is like a safe green bubble bath for metals. That's basically what these are: biodegradable, low-toxicity, liquid salts. But here's the real kicker. Using DES doesn't just make the process safer, it actually produces smoother, more uniform coatings that are even more resistant to corrosion than what the old, dangerous acid baths could do.
Next up, we have a direct fix for one of the biggest problems out there: cyanide-free electrolytes for silver plating. By switching to solutions based on thiosulfate, industries like jewelry and electronics can get that brilliant silver finish without exposing anyone to super toxic cyanide. It's an absolutely crucial step forward that delivers the quality people expect while making safety a priority.
And finally, there's this one, which is just so cool: plasma electrolytic oxidation, or PEO. This process is kind of like creating controlled lightning inside a special water-based bath. Tiny electrical discharges create plasma, which then grows an incredibly hard ceramic-like layer right on the surface of metals like titanium and aluminum. You end up with this ridiculously durable coating, all without using any harsh chemicals. So the main takeaway here is that these new methods aren't compromises. We're not trading performance to get safety. We're actually getting better performance because of these safer methods. We're talking better finishes, safer workers, and ultra-durable coatings. It's a total win-win-win. But here is where the story takes this really fascinating turn. This whole green revolution wasn't just about replacing old, dangerous methods. It sort of accidentally unlocked a whole new world of creative and aesthetic possibilities. This quote from a recent study, it just captures the plot twist perfectly. Researchers were developing these super strong PO coatings, and they discovered they could also precisely control the color. The same process that makes a surface tougher can also make it a specific shade of green or blue or black just by tweaking the settings. And this shows you just how much control we're talking about. By adjusting the electricity or changing the recipe of the electrolyte bath, or even just how long you treat it, scientists can basically dial in the exact color of that final ceramic layer. What started out as a purely industrial process is now becoming something like an artist's palette. And it doesn't even stop with color. When you combine these new coatings with something like precision laser texturing, you can actually sculpt the surface at a microscopic level. This lets you control exactly how light scatters off of it, creating finishes that don't just look different, but have a real tactile quality to them, almost mimicking the look and feel of materials like silk or velvet. So where does all this lead? Well, these new surfaces aren't just green and beautiful. They're also way smarter and higher performing than anything we've had before. Okay, here's a perfect example. Remember that hazardous hard chrome plating we talked about? Well, it's being replaced by a process called electroless nickel phosphorus, or NIPE. The old method, it used a carcinogen, and it often left behind tiny cracks and uneven buildup on the edges. The new NIPE process is not only way safer, but it creates a perfectly uniform, totally crack-free coating, even on really complex shapes, with wear resistance that's just as good or, in many cases, even better. And get this, we can even stack these technologies on top of each other. So, imagine starting with a laser to etch a really precise pattern onto a piece of metal. Then you apply one of those colorful, super durable PEO coatings right over that texture. What you get is a single surface that has it all. It's incredibly resistant to wear and corrosion, and it has this unique, customized look and feel built right in. And the applications for this stuff are just profound, especially in medicine. Using POO on a biomedical implant doesn't just make it last longer, it can actually help it integrate better with your bone. But it gets even smarter. By adding elements like silver or magnesium into that coating, we can create an antibacterial surface that fights off infection right where it starts. The porous surface can even be engineered to hold and slowly release drugs over time. It's amazing.
So, where is all this heading? I mean, what does it really mean for the world around us?
Well, the really big takeaway from all of this is that we no longer have to choose. For years, making something high performance, making it beautiful, and making it sustainable were three totally separate and often conflicting goals. These new technologies have merged them all into one. The innovations that make a product greener are the very same ones that are making it stronger and more aesthetically versatile. So the next time you see a brilliantly shiny or a really uniquely colored object, take a second look. You might just be looking at the future of manufacturing, a future where the most sustainable choice is also the strongest, the smartest, and the most beautiful one. And it makes you wonder, what are we going to create when those old limits are just gone?